Today we will study about quotient rule of derivatives, and the goal here is to try to find the derivative of a function fx, and this function itself can be represented in the form of ratio of two functions ux and vx. So ux is a much simpler function and vx is also a much simpler function as compared to this complete function fx. So if you see a format like this, you will try to uh, differentiate the numerator and denominator separately using this quotient rule. So let's see what is the formula. So if there is a function of x fx and it can be represented as ux divided by vx. For example, you have sine x by 5x plus 3 or maybe some other polynomial function. So you see that this function has two parts. One is numerator, which is ux. It itself is a function of x, and this is another function of x, much simpler than the original function fx. So you will differentiate them separately using this formula. So the formula is that if you want to try to find the derivative of this fx, you can find the derivative of numerator multiplied with denominator. So u prime x vx minus ux v prime x. So here you have both the terms ux vx in both of them. In first one, you are taking the derivative of numerator and then denominator. You cannot change the order since we have a minus sign in front of this term. And in the denominator, you divide by whatever was the denominator, you square that. So we will see one example of this or two examples using this quotient rule. Then we will also see how to prove it. For those of you who are interested, they can continue in the end to see the proof. Otherwise, you can skip the proof. So let's see the example. I have written the formula also here so that it's a reference for your example here. So you see this is ux. This is vx. So u prime x, that is derivative of x cube, which is 3x square, and vx is sin x, minus ux remains and derivative of vx, which is cos x, and divide everything by square of this. So it becomes sin square x. You can also write sin x whole square, both are same thing. For trigonometric functions, you can write square or cube here itself before this parameter. And this sin square x is same as sin x whole square. This is the way to represent the trigonometric functions. So this, you see how easy it becomes. You can solve it in one step if you are using the quotient rule. Now let's see some other examples for which we know the answer. Here we don't know the answer, so how can we sure that this is the correct answer? This is giving correct result. Let's see an example of some function for which we already know derivative. Let's say we try to find the derivative of x raised to the power 5. This here we will not be using a quotient rule for our practical cases, but here we will prove that quotient rule also works here. So directly using power rule, we know that it's 5x raised to the power 4. 5 comes as a multiplier and power is decreased by 1. So what we will do here, we will write x raised to the power 5 as x raised to the power 7 and divide it with x square. So these are same terms. This 2x square will cancel 2 of this power and we will get x5. Just to write fx in the form of ux divided by vx. So this becomes ux, this becomes vx. So what will be the derivative using this quotient rule? U prime x, which is 7x6, we multiply by vx, that is x square. And then subtract ux and derivative of Vx, that is 2x, and divide everything by square of denominator. So x square becomes x power 4. Now the first term is 7x 8 minus 2x 8, and everything divided by x4. Then we have here 5x 8 divided by x4. So this 4 cancel 4 of the 4 from 8. So we are left with 5x4. So you see this answer is same as this. So you see this works, and you can apply it to even simpler functions, but it's not required here. It was just to give you a sense of that this function is working correctly. Now let's see the proof of this. So for those of you who are not interested, you can skip it. But if you are interested, you can look at the proof. So the proof will be very similar to the proof of product rule, where instead of ratio, we had the product of two functions, ux, vx. So using the first principles, f prime x of this term, we can write as ux plus h divided by vx plus h, and we subtract ux vx divided by h, and we are using the first principle, which is f prime x equal to fx plus h minus fx divided by h. H is infinitesimally small. So we have just applied this formula here on this function. Now we take the LCM of these two. So ux plus h, vx is multiplied here, minus ux vx plus h. And the common denominator now becomes the product of this vx plus h vx, and also this h. And again, this is carried forward in all the steps. Now what we will do, we will add and subtract some term, just like the case we did in product rules proof. So ux plus h vx minus ux vx plus ux vx. So you see we subtracted and added this, so this does not make the difference in numerator. And the last term is ux vx plus h, everything divided by h. And let's take this product. So if h is very close to 0, this vx plus h becomes same as vx. So we get 1 over vx square. So I'm just writing these two terms separately, and this limit continues. So if you take the first two terms, we get vx is common here, so ux plus h minus ux vx plus, or rather minus, you remember here minus, so we have some hint if we know the formula beforehand. But even if you are not knowing the formula, we will arrive there ultimately, because we are always trying to find this kind of pattern, fx plus h minus fx divided by h. So here this term is positive, this term should be positive, so we will take minus so that this term becomes positive. So Vx plus h ux minus ux vx, and this term is carried forward, vx square, and divided by h, so we can split it and divide them by h separately, and this limit is here also, and this is multiplied to everything, 1 over vx square. So what is this term? Ux plus h minus ux divided by h. This is u prime of x. So u prime of x vx. So this term we have taken care of. Now let's see the second term. So here what is common? Ux is common. So minus ux, and what will be left? Vx plus h minus vx divided by h, which will be v prime of x. And everything is multiplied by 1 over vx square. So we write that also. And you see this, we arrive at our formula. This is the final formula, which is same as this.